Okay, so we'll get to the scheduler, and I'll have that as a separate video. But one thing I wanted to clear up was just going over the code for the producer and consumer. I don't think we really need to visualize what's going on with the array so much as just seeing what's going to happen to make both the producer and the consumer go to sleep, which would then mean your program's just sitting there doing nothing. So the idea is that we could be in the consumer code like we see, and it's going to have to at some point check whether there's nothing in the array for it to be able to consume. So in that case, it should just release the CPU, let something else be scheduled to run by making a call to sleep. But the problem is that let's say the array is empty. So this check for count equals 0 is true. But right in between that check and then moving on to the execution of the function call to sleep, we could skip, and the CPU could be scheduling any other program it wants, and that could be the producer. And the issue there is that, let's say it goes to increment next, so that the value of count then becomes 1. And then when it checks to see that count is equal to 1, it has to perform this check because it wanted to take care of the consumer to let it know that if the array was empty, then it created something and placed it as one more element in the array. There's something there to be consumed. So in that case, it thinks the consumer was asleep, and so it should make a call to wake it up. So if it sends that function call, but the consumer's not actually asleep, that wake up function call basically gets ignored. And then later on, we could go back to scheduling the consumer. And right where we left off, it would then make a function call to sleep, even though there's something there in the array to be consumed. And so then it's going to wait for that wake up call from the producer. So we go back to the producer code. It could then just continue to fill up the array until it's completely full. And then it checks, okay, is the array full? We've got n elements in it. And at that point, once the array is full, then it would also go to sleep. And so then we would have both the producer and the consumer asleep, and there would be nothing to make a call to wake either of them up. So this is what they really meant by race condition. I know this one was a little bit more to try to think through with me. So I think after a couple hours of talking, I kind of lost track of where we were going with it. And I think it's good to see it a second time anyway, because we were going through so many concepts. So just be aware that when we're writing code that could be run in parallel, and you maybe have threads that are executing in parallel like this, one thread might be the producer, another thread might be the consumer. You could have the code switching back and forth between them at any point. And that's why we got into this topic of semaphores and mutexes, and they give you the rewritten code for the producer and consumer, making use of the POSIX library. This one they give you in general first, but then after we had walked through that in class, you could tell we were trying to control, well, when is it going to allow either the producer or the consumer, only one at a time, to be able to access the array. And here the producer is only going to get that chance to insert an item when the mutex is controlling the critical region, so that we don't have that issue anymore with potentially the consumer getting in the way for the CPU just automatically switching somewhere in the middle of that. If the CPU tries to schedule like that into the consumer, it's not going to allow it to continue to go into the critical region at the same time that the producer's there. So they can't access the array at the same time, or the buffer. And so we want those mutexes to control critical region. And then we had a couple more. We had the semaphores, one for controlling access in the array if it fills up. And then there's no more that are empty. And that's almost like a backwards way of naming things, but they're keeping track of how many elements are empty with that semaphore to know when to put the producer to sleep if empty reaches 0, because if we make a call to down on empty, it will decrement the value. And then in the case of the consumer, we're using how many elements have something there. So the semaphore for full does the same job in the consumer. And if we call down on how many elements have something, and full becomes 0, then it would go to sleep. So remember, when we're making a down call, we're decrementing. And so potentially these calls to down would put the code to sleep so that something else could execute. So in this case, the consumer would go to sleep if full was 0, and then the producer could run to create more elements in the array. And then otherwise, if there are things there, it can use them up, go into the critical region, and then when it's done accessing the array to get the element it wants, it will call up on empty to let the producer know that it has more room to create items, to increment the semaphore. And we can control with scheduling, even though we're not the ones that are deciding what is going to execute next, we're still controlling release and then entry into the critical region, and then potentially what we'll execute with just our code, even though the CPU is deciding like any kind of code that could run. So if I have many, many programs on my computer running all at the same time, just keep in mind that it's switching between those all the time. But we get a little bit of control with specific kinds of conditions with the down and up on the semaphores. And the last thing I would say here would be when they show you the third implementation, where we get very close to the C code. We didn't talk much about the condition function calls for the way they're using semaphores, is that it corresponds to these up and down calls inside the producer and consumer. So when we look at the consumer code, we've got the mutex lock to go in to access the buffer that's controlling for the critical region. And then it looks a little bit different when you're actually writing the code from the way they were just giving you a simplified version of it. What you want to do when you're doing condition wait is you're checking on the condition that the array is empty. So there's nothing left to be consumed. And so it's going to wait on that condition variable for you. Effectively, this is like the semaphores that we're decrementing down until we check it and it becomes 0. It's doing the same kind of job, even though it's not really keeping track of any kind of integer that's incrementing like that. It's only just checking the condition for us. So when we're making a function called the pthread condition wait, it'll keep track of that condition when our buffer is empty and associate that condition with that variable so that we can wait, we can let the producer execute while the consumer waits. Right? That's all it's doing, is just allowing something else to execute. And then it's going to get at some point the signal that the producer is going to make. So I'll go back to the code for the producer. And you can see that it's got this pthread condition signal function call, and it's on the same condition variable, condition C for the consumer, for when the array was empty, when the producer creates something for us, right here, it's adding one more element to the buffer so that it can be used by the consumer, then it can tell the consumer to wake up with a condition signal function call like that. So that's all we're doing with those function calls. We're releasing things from being scheduled on the CPU, or we're just sending out a signal to wake them up so that they could be scheduled later. And we'll definitely get a chance to see code like this execute. We'll do demonstrations. And then we'll get more comfortable with it when you can actually see the code executing rather than just listening to me talk about it.